So, today we will study about the channel, the transmission channel or the media on which the transmission is actually takes place, and in computer networks what is the role of the channel or the transmission media. We know that in the reference model that we have studied, at the bottommost section we have the physical layer, above which we are studying currently is the DLL, the data link layer. We studied the services, the functions, those are being offered by this data link layer, like your flow control, error control, framing, the protocols associated with those things, everything we have studied. Now, if you see the DLL or the data link layer takes the services of the lower layer, that is the file layer, and in the sender side what it does, it generates the frames and sends these frames to the lower layer. At the receiver side what happens, the file layer receives the frames and those frames are now transmitted to the DLL at the receiver side. This is at the receiver side. So, in both the cases, either at the sender side or at the receiver side, in both the side you see that the DLL or the data link layer actually deals with the transmission, it handles the physical transmission of the data other than the file layer. File layer actually does the transmission, but who takes care of that or who supports the file layer is the data link layer. So, this data link layer, other than its functions or the services, it is also very popular to know or to deal with the channel. So, this DLL at the sender side or at the receiver side is divided into two sub layers. The DLL of the reference model is divided into two sub layers. One is the logical link control layer and another is the medium access control layer. The reason behind the MAC to be at the bottom side than the LLC at the up side, reason is MAC is actually dealing with the medium or the transmission media, the channel. So, the lower layer of the DLL is known as the MAC layer and the upper layer is the LLC layer or the logical link control layer. When LLC deals with all the services and the functions, the MAC layer that deals with actually the transmission of the data or the frames that it generates. So, when the frames are generated, the frames from the MAC layer it goes to the file layer or the transmission media. So, how a node or a station is assigned a channel or a media is the responsibility of the MAC layer. Consider a point to point communication. What happens here? You have a single sender, you have a single receiver. So, the channel that is connected between these two has the complete access for the stations, the sender and the receiver. So, when there is only one communication point to point between the sender and the receiver, there is no question or there is no competition for the channel, because the whole channel is dedicated to this sender and the receiver for their communication, and point to point communication is no more of use because people are having so much of data to transmit, you cannot think of even point to point because it is not affordable. Now, think of a situation when you have a multiple transmission, how the multiple transmission takes place. So, when multiple nodes are connected, you have a channel and multiple stations are connected to the channel. At that time, who gets the channel first or who gets the channel to complete its transmission within a certain time is a major challenge. So, a layer, a complete layer has been assigned to decide, to see that the channel has been allocated to a station who has the data ready to transmit, and that this transmission should not be interrupted without the information or without intimating the station who is accessing the channel. That is what is the job of your MAC layer. So, the first thing what we will study is, now with this related to this channel, what we will study is the channel allocation. When you have multiple access, how you do the channel allocation? The channel is allocated to which station and how it is being done. This channel allocation is broadly classified into two types or two varieties. One is the static allocation, another is the dynamic allocation. And this static allocation can also be called as a centralized kind of allocation. This is also called centralized and this is called distributed in some sense. In the static allocation or centralized allocation, what happens? Usually the nodes or the multiple stations are assumed they are physically located to each other, I mean nearby located to each other. They are connected to each other, and to have the connection or to have the transmission, they are connected to a particular device called a multiplexer. You must have heard this name, multiplexer. This is a physical device to which all the stations will be connected. So, the technique that is being used by this multiplexer and the corresponding device is a demultiplexer. When multiple nodes are connected physically nearby or close by proximity, they are connected with the devices called the multiplexer and the demultiplexer, and the technique is called the multiplexing technique. We have multiplexing. In this multiplexing, what happens? You have a MUX or a multiplexer that connects all the multiple nodes to itself, and this multiplexer is connected to actually the channel or the transmission media at the sender side, and at the receiver side this is connected to another device called a corresponding demultiplexer. If this is a MUX, this is a DMUX, and this is now connected to the corresponding receivers of these senders. So, senders are connected to the multiplexer, receivers are connected to the demultiplexer, and this decides which signal or the corresponding sender with the corresponding receiver, the signals are being delivered accordingly. You know, there are different kind of multiplexing methods. The very common kind of multiplexing that is used in computer networks or any transmissions are, the very common one is a time division multiplexer, time division multiplexing. In this multiplexing, what happens? Your whole of the transmission time, if the transmission is decided to be carried out for 1 hour, then the total time is 1 hour, and the time is divided into number of slots. Let's say 60 slots have been created within this 1 hour time slot. For each slot 1 minute is allocated. So, that means you have total 60 number of slots that has been generated for the transmission, and each slot, this is a time slot, each time slot, during each time slot the whole transmission channel, when I say transmission channel means I mean the bandwidth for the channel, because that is the major resource of any transmission or communication. We do not talk about the sender resources, we do not talk about the receiver resources. During transmission, we always focus about the channel resource, because that is a constrained resource and very, very expensive resource. So, that has to be optimally allocated to all the nodes, so that everyone get a fair chance to transmit their data, right. So, what happens here? Now, if you have a channel of, let us say 1 MB capacity, then the whole of the channel is allocated to a node during this 1 minute time slot. Let us say you have 5 users, or let us say you have 60 users, say you have 60 users or 60 stations, and each slot is 1 minute. So, accordingly total transmission has been decided for 60 minutes or 1 hour. That means every node starting from 1, 2 to 60 number of nodes can be allocated to the channel during their slot. So, whenever the third slot comes, the third minute comes, the station number 3 gets the whole channel for its transmission. Similarly, at the 50th minute, the node whose ID is 50 gets the whole channel to transmit. That means the time is divided between the nodes, and whenever a node gets the channel, he gets the whole of the bandwidth to transmit. With an assumption, on an average the nodes should be able to finish their transmission within 1 minute. If they do not, they have to wait for the next slot that will be allocated to them, correct. That is what is your time division multiplexing. Now, in this technique, tell me what could be the flaw for the transmission. Maybe very time slot you say, but on an average they have seen that 1 minute is enough for a node to transmit on an average. So, they have decided, let us see. That can be a such situation also. It may happen that let us say a node, node number 3, node number 3 has huge data to transmit. Let us say it needs at least 5 minutes the data to transmit. Total transmission time is 1 hour. So, 5 minutes, the node number 3 wants 5 minutes to transmit, and the other nodes, other slots that are been allocated to the other nodes, let us say most of the nodes are not ready with the data. Not ready with the data means what? The data is not yet generated or the frames are not yet generated, right. So, they are not ready with their data to be transmitted. So, what they during their slot they say deny, the decline to transmit. So, out of this 60 slots, let us say 50 slots comes with a decline message and 10 slots comes with an accept message, and out of that only one node has a huge data which needs 5 minutes or 5 slots transmission. During the transmission you don't you have 5 slots that could be allocated to node number 3? You have, because you have total 60 slots and all those slots have come with a decline message, right. That means you are underutilizing the channel resources or the total transmission time by letting the one of the node to wait for a indefinite period or for a long period to finish its transmission when you have other slots free for that. So, TDMA or the time division multiplexing, though it is a simple kind of transmission, but the flaw associated with this is the underutilization of the transmission time. Another kind of multiplexing method is the FDM, frequency division multiplexing. In this method, what the basic thing that is being done is your total bandwidth or the spectrum, what you say, the spectrum is divided into number of slots. If you have a channel of 5 kb, then this is, let us say, this has been divided into 5 virtual channels inside or bandwidths, with every channel or every band separated with a special kind of signal called, anybody knows that? Guard band. It is like your framing. If you remember, framing means what? Framing with the frame boundaries. Any word you write the word with space at both the side. Similar way, when the bands or the bandwidths are generated or the channel or what you said spectrums are generated out of the whole channel available or whole spectrum available, all these spectrums or these bandwidths are separated with another kind of small signals called the guard bands. They also occupy some small space or bandwidth, right. So, again now these guard bands along with the channels are created inside the whole channel or the available channel bandwidth, and each sub channel is allocated to any number of stations or the nodes. So, 5 channels, 5 stations are allocated, and the stations are allowed to transmit only within their spectrum. They cannot go beyond their spectrum. If they need any extra bandwidth for their transmission, they are not allowed to do so. So, drawback in this case is also similar to the TDMA. Let us say one node, one station wants 2 kb of channel bandwidth, but he is not being allowed because he has only allocated with 1 kb. So, the rest of the things he cannot use. That means these are all the static kind of allocations in which the nodes are provided with the resources, but with a fixed resources which cannot be change as per their requirement at any point, right. Now, other than this FDM, there is another variation of this FDM is the WDM. What is this? Wavelength division multiplexing. This is similar to your FDM, the only difference is that WDM is used for optical fibers. This is only used for the optical fiber. The reason is that optical fiber has got huge bandwidth. So, your FDM cannot be used for your optical fiber. So, this has got its own multiplexing mechanism or the technique, that is called your WDM. There are several other multiplexing techniques, CDM, code division, all those things. We are not currently we are not working on that, but what we will see is the FDM and TDM and the WDM. All the MAC layer functions are basically working on, or they are, the principle is on this, any of these multiplexing techniques. So, what these all techniques they do, they come under the static or the centralized kind of channel allocation method, which has got a drawback of not providing the resources sufficiently to any channel who is having the data to transmit or who is ready to use the more of the channel resources. So, the next version of this one is your distributed or the dynamic channel allocation. In this channel allocation, what happens? You have the dynamic channel allocation. What happens here? A node who is connected to the channel, let us say n number of nodes are connected to a channel, and any node who is ready to transmit by different mechanisms or by different rules, they enter into a certain protocol, you can say, in which they will be allocated the channel as a whole for maybe some particular time period or maybe on some priority basis or maybe some other strategy, and during that only that channel, the whole of the channel will be owned by a station who has owned it or who has captured the channel, you can say, and he can transmit it. So, dynamically allocation of the channel, that is what is a different MAC protocol works with, and with this we have to work on certain assumptions. Before designing any dynamic allocation of the channels, there are certain assumptions that has to be taken care of, and the first assumption is that you think that, or the first assumption is every station or every node are assumed to be independent. What do you mean by independent? A station is called an independent station or a node, let us say node or station or any device I am saying, that means a sender is an independent device. What do you mean by independent station? Your computer, when you are working with a computer, is that an independent system? Who says yes and who says no? Is that independent? Who says that is not independent? Even with out of two choices, you do not have any say, right? That is independent or not? Why independent? Let us say you are working on a system, I am working on my system. At some point I will give a shutdown message, your system will be switched off. Will that work? So, your system is an independent system, you have the authority of your own system and you are working, all the resources that belong to that station or the system is independent of others accessing or others accessibility, right. That is what is an independent system. If one system can interfere with the resources of other, we do not say that is an independent system, right. So, first assumption is that, or what we say is a station model. How you model a station? We say that the stations or the nodes are independent. Then second assumption is that you consider multiple stations are there or multiple nodes are there, but the channel to which they are connected is a single channel. If you have multiple channels with multiple stations, that becomes again a point to point communication. So, no point of considering MAC again, right. So, the second assumption is that you have a single channel option. That is obvious because we cannot have multiple channels, it is difficult to afford multiple channels. So, we consider you have a single channel where multiple nodes are connected here. Now, you can say if multiple channels are connected in this, why not we are going for multiplexing? Why you are going for this again another kind of dynamic allocation? Multiplexing has got another restriction. The nodes need to be physically close to each other to be connected with the multiplexer. But in a dynamic model, geographically the nodes could be anywhere, but they need to be connected only to the cable or the channel. When I am saying about the channel, I am saying about the wired channel. We are not yet discussed with the wireless. We are not going to the wireless model. What we are considering is a wired channel, maybe a fiber optics, maybe a coaxial cable, but it is a wired channel or wired cable. And throughout the span of the channel, a node could be anywhere. Multiple nodes can be anywhere in the, but they are connected to the channel, right. So, we have a single channel assumption. The third is, in a single channel, definitely only one signal can transmit it at any point of time. A single node can transmit its own data into the channel. If two nodes transmit, what will happen? There will be a collision. The data will be garbled and ultimately it is a loss of the data and the transmission is waste. It is an unsuccessful transmission. So, that means whenever there is multiple signals, the third assumption is that there should be an collision when multiple signals are inside the channel, and this collision should result the data loss and subsequently the retransmission, all those things. That is what is your third assumption. The next assumption is that every node is associated with a timer. You remember the retransmission, the timeout, all those things, meaning what? A node when transmit, it sets its timer saying that this is the moment I transmitted my frame and I need to wait for certain time period, delta t time, to get back the acknowledgement or NAC or anything. So, every node must be modeled with a or equipped with a time, and this time could be, we say that that is a time model. This time could be a continuous time or it could be a slotted time. What happens in this? Let us say multiple nodes are there. The whole of the time is divided into number of time slots. Either all the nodes, all the multiple nodes will be synchronized to one timing. That means they should have the single timer model and everyone has to work with the centralized timer. So, they work accordingly, or they can have their own independent timing or the continuous time you can say, and they can work accordingly. So, either you have a slotted time or you have a continuous time model for the transmission. And the next assumption is, the fifth assumption is the carrier sensing. What do you mean by carrier sensing? Carrier sensing or no carrier sensing. What is the carrier here? The channel. The node should have, every node that is connected to the channel should have the provision of sensing the channel, meaning to understand what the other nodes are doing at this time. And they have a specific kind of message, you can say they can send a beacon message. Usually what they do, they send a single pulse and or a beacon message, and that beacon when garbled with another beacon, some feedback mechanism is there which comes back to the station saying that some other node is transmitting in the channel. So, my signal has been collided with that, and that means the channel is busy, it is not idle. So, the objective of having this carrier sensing or no carrier sensing is to find whether the channel is idle or it is busy. Depending on that, you can design the different protocols. So, with all these 5 assumptions and 5 models, you can have a different MAC layer protocols or the what we say rules for transmission into the channel, the MAC protocols, the MAC protocols. Similar to your DLL protocols, the data link protocols, for every function, every job there is a protocol required, like your for flow control you had a protocol, for error control you had the protocol, different protocols again you have the different strategies, they have different principles, all those things. Similar to that, you have when the multiple nodes are accessing a single channel, your MAC layer plays an important role with its own set of protocols. We say them the MAC protocols. And these MAC protocols are again classified into different types. One is the contention based MAC protocols. What do you mean by contention? When this term comes contention, what is contention? Have you ever heard this term contention? When multiple stations trying to get a single channel, they have a competition, they enter into a kind of bidding, they enter into some strategies, something with some collision with something and some resolution, ultimately one node wins and he gets the channel to transmit. So, the process by which multiple nodes try to get the channel resulting into any kind of collision is called the contention. They are contending means they are contending with the other nodes to transmit, or to get the channel, you can say. That is what is the contention. So, contention based protocol means everyone is allowed to contend to get the channel. Contention free means before contending or before they try to get the channel, there should be some protocol which will prevent them to contend. By some protocol, by some resolution, by some method, they are being allocated the channel, so they do not have to contend with others. That is what is your contention based protocols. There are few protocols which are contention based protocols. You allow the nodes to contend, and when they get the channel, they will transmit. That is what is the contention based protocols. Then another protocol is another classified or the type of protocol is the round robin protocols. Round robin everybody knows, right? Some strategy you apply so that a node gets the channel, and after some time, after one cycle, you can say he gets the channel again. So, there are some mechanisms in a round robin fashion, he gets the channel with some, usually it is a token based protocol. The token is allocated to him in some other way, so that he gets the channel and does the transmission. That is what is your round robin method of transmission. And another kind of MAC protocol is the contention free protocol. This is a kind of protocol, as I told you. In this, the channel or the allocation of the channel to any node is made in such a way that the node before contending or before some other collision takes place, he gets the channel or he is allocated the channel beforehand. So, the collision is not at all allowed, or the contention is not at all allowed. Before entering into or before getting the channel, they have to enter into another kind of process in which the contention is resolved and they get the channel. It is like you have this door, 10 people wants to enter into the room, there are 10 seats only there, right. So, what do you do? All of you try to get the, try to enter into the channel, some fails and some are able to enter, so they get the chair. It is a contention based. There are some other way, if you have a ticket, then only you can enter into, otherwise you do not. So, beforehand you go and register, get the ticket and enter inside this. So, there is no question of contention. You have the ticket means you will get the channel or you will get the seat. So, that is a contention free kind of protocol. Ultimately, the objective is to get the channel, whether you enter content for that or you do not content. That is where according to that the protocols are being classified. So, coming to the contention based protocol, first we will see the contention based protocol. There are certain protocols, transmission or MAC protocols, very common is the Aloha protocol. One of the very common contention based MAC protocol is Aloha protocol. What this Aloha protocol, this was again, if you go for the history of this protocol, this was the first of kind protocol, and again this started by the defense people, the Department of Defense of US. What they did to during some war, they wanted to transmit the packets, right, and they did not have the channel, they did not have dedicated channel for that. So, what they did, they tried to send the packets or the message. Some of the messages were successfully delivered and some were collided. So, once collided, they could understand that there is some problem So, they waited for some time, again they tried with sending the transmission, and they found that after waiting some period, if I am sending, I am getting a successful, I mean the transmission is successful. So, that was become the principle of the protocol, the Aloha. What the Aloha protocol says, if you have multiple nodes, let us say you have four nodes A, B, C, D or 4 stations, and whoever is ready, any node whoever is ready with its data, let us say node B is ready with its data. So, what it does, immediately as soon as he is ready with the data, means I am saying about the frames, as soon as the frame is generated, it releases the frame into the channel, right, and the node has again got the provision of getting back the acknowledgement in a positive or a negative way. That means it can sense whether my transmission feedback, it gets the feedback whether my transmission was a successful transmission or it was a failure. So, once it transmits, then waits to get the feedback. Let us say the transmission was a successful transmission, over. Let us say during this transmission time, another node C, this fellow was also ready to transmit. So, he released the frame into the channel. What will happen now? The data, partially the data is collided, right, because the time overlaps. When this transmission is going on, this transmission is also going on, and the data is collided. And as soon as the data is collided, both B and C, they get a message or get a feedback that there occurs as collision. Let us say at 5th second, both of them get the message that there was a collision, B and C, right. So, now they have to stop the transmission, they have to wait for random amount of time period, they wait for random time. Why this randomness has been included, you can understand. Let us say they wait for random time, and this random time is, let us say for B it is 3 and for C it is 1, right. So, as soon as this timer expires, the random timer expires, the node again tries to transmit. So, who gets the transmission, I mean get the channel first, who is ready to transmit again? C. So, now C at 6th second, C is ready to transmit. So, C what it does at 6th second, it again starts its transmission, and let us say B is ready with 8th second. At the beginning of the 8th second, B is ready to transmit because the random waiting time is expired and now he is ready to transmit. And during this 6th and 8th second, 2 seconds has been elapsed, and that 2 seconds was enough for the node C to transmit the data, maybe. So, the probability of getting a successful transmission is now better or more, you can say. If they do not wait for random time and they wait for a fixed time, what will happen again? Every time they are ready to transmit, there will be a collision, and ultimately whole of the transmission time is only the waiting time, because every time they try, there is a collision, they defer, they wait, same time period, and that continues. So, it is a simple kind of protocol. None of the nodes are restricted to transmit, only at the time of collision they have to wait, otherwise if they are ready with the data, they can transmit at any time. So, only probability is the overlapping of the timing between which they transmit the frames into the channel. That is what is the Aloha protocol, and this Aloha protocol uses your continuous time model. As I discussed, it uses the continuous time model. The reason is, see, no one is waiting for the other's time, there is no central timing required, no synchronization is required, whoever is ready sends the data, right. So, to improve upon this or this continuous timer or this waiting time, then they had another kind of protocol or the improvised version of this protocol, which is the slotted Aloha protocol. How this slotted Aloha works and what is the principle of this slotted Aloha, how it improves upon the efficiency over the Aloha protocol, we will see in the next class.